Let's enter this into our calculators first and foremost. Maybe you already did, but I think it doesn't hurt. The reason I want you to practice is because I designed these for you to have to change your window, play around with the zoom. Sometimes you're gonna get an error if you don't do it. Like all those things, I want you to encounter that so that for a quiz you're ready, your test you're ready. So I'm just gonna enter it the way it is. Remember, even for grade 12, no matter how ugly the equation looks like, you just enter it into your calculator, right? We're going to enter this into y1. I know it's f of x. It doesn't matter. It's still a function. It's a function notation. You can write it if you want to. You could still say this is y is equal to x minus 8, x plus 15. It would not change anything. Okay. You can tell it's a quadratic because if you FOIL that out, you would get an x squared term. And so let's see here. Form. This is actually factored form. So there's the vertex, which has just one bracket. Factored has both brackets. And the opening, let's see here. This will be A is positive, correct? Because A is right up front always. That's where A is located. So it'd be pointing up. The width, A is equal to 1. So this is a normal. The width is normal here. And y-intercept, you need to use your calculator for that one. Vertex, you need to use your calculator for that one. Axis symmetry and equation of min-max, we get it out of our vertex. But here's where I want you to, we're gonna verify this with the calculator, but I can tell you already, when it's in factored form, these are actually giving you a hint of what the x-intercepts are. I can tell you that the first x-intercept is 8 positive, and the second one is going to be negative 15. So it's always what makes this 0, what makes that bracket 0. That's what you want to think of, because that's when y is going to equal to 0. That's when you have your x-intercepts. Okay, so this would be negative 15, 0, but we're going to confirm that with our calculator. It's not absolutely crucial that you remember that. It's just I like the pattern. So if you can think of it, it saves you some time. So let's enter it into our calculator. I'm making y2 equal to 0 already. I'm going to hit graph now. Okay, let's do some investigating here. I know that my parabola goes like this because I know it's pointing up. This leg is the right leg of it. So now I know what to change, right? I could go to my window, change the y min, lower it, change the x min, right, to the left, and then probably I have something. But before I do that, I might try zoom, I'll do zoom fit. It tried, did a pretty good job. It has that x-intercept, the y-intercept, and the vertex. It's a little shaved off, but that's okay. So all we need to change now is our x min. So I'm going to go window, x min. I'm going to change it to negative 50. How did I come up with that number? I just guessed. Right? Y min, I'm going to go negative 150 on that one, right? Because the y min, it was kind of cutting off my vertex. Negative 150, not minus. You got to press that negative in brackets, or else it's going to complain. And then I hit graph. It's overkill, I know. Negative 50, x-min was a little overkill, but that's okay. You see the graph, that's good. Okay. Now we're going to go find the y-intercepts. Please tell yourself and tell me what you're using. To get the y-intercept, I'm going to use second, trace, value, x equal to 0. Okay, that's what I'm going to do there. So second trace 1, x is equal to 0, hit enter, and you get negative 120. Okay, negative 120. So 0, negative 120. The vertex, we have to use min or max, right? So I'm gonna say here second trace. Look at, I'm gonna go back here. It's pointing up. It's doing this. So my vertex is the minimum. It's the lowest point. So I have to use min here. Okay. So second trace minimum. And again, this is the vertex. It's asking you for a left boundary. So you're going to go to the left of it, hit enter, move over to the right of it, just press and hold, okay? Enter, enter. And there it is. It's negative 3.5, 3.50, negative 132.25. Always round to 2 decimals when you write them down on paper, okay? That's important. So there's that. Axis of symmetry, and both of these are we take from the vertex. So that's the axis of symmetry, the equation of the axis of symmetry. This is a line, okay? It's a vertical line. And then the equation of the min, you circle min, so that'd be negative 132.25, also a line, horizontal line. Let's find the intercepts and just verify. So to find the intercepts, I'm going to put the keystrokes down again here. Y2 is equal to 0. Second, trace, intersect. As we move on, I will start changing it to like second trace 5, because 5 is intersect. So you can shorten it down the road. Maybe I'll just keep it. Like it doesn't take that much time. It beats factoring, right? Like imagine like the other way would be factoring, and we don't really need to do that. Okay, so here we go. Y2 is equal to 0. It's already done. I hit graph. Then you go second trace intersect. Let me rephrase this. What is this thing doing? It's saying, because remember, you could have 10 curves in there, guys, and they all kind of cut into each other. So this program is saying, hey, what's the first curve you're interested in? Well, it doesn't matter technically if you're on the blue or the red. Those are the two you're interested in. So you give it any point on that first curve that is, and it's going to find the closest intersection to it. So if you move closer to this one, that's good. That's good enough. I would just hit enter 3 times. So 1, right? It kind of followed you along on the other curve, and then just press enter and enter 1 more time, and then it kind of just narrows down to that one. It just finds that one. So that's the negative 15, 0 intercept. Then you find it 1 more time. Second trace 5. I'm going to now scroll over to that one. As soon as you, like, it's always going to go to the closest intersection, okay, guys? Right now, you're closer to that one. So if you press enter 3 times, it's going to find that one, which is 8, 0, which I already have down, okay? So that's how this is done. The domain, I like this one the most. In this case, it's easier, but you do whatever you want to do there. The range, how would this go? Y, it's pointing up, right? So Y has to be greater than or equal to the Y value of the vertex. Or you can write it negative 132.25 to infinity, and it has to have round here, square there. Smallest followed by the greatest number, right? That's how it goes. Yeah. I will come and see you. Anybody tried 2930? I'm not sure if you did. If you didn't, it's not off the table. It's still there. Okay, it's waiting for you. And I almost forgot, but my goal is to do that with. See an example of an equation that is not quadratic. So basically, no x squared term. That's all you need to make sure you account for. So examples would be y is equal to x, y is equal to 1/2 x plus 3. You can actually go y is equal to 8, just a constant, right? Anything that doesn't have x squared would be acceptable here. So that's all I was looking for. Explain when you could have a quadratic that produces a parabola with no x-intercepts. So you could say, well, this is a scenario. And so when I talk about these two, I would say A is positive. What's A? Leading coefficient, right? Leading coefficient. A is positive. And the vertex is, A is positive and the vertex is above the x-axis. That could be one instance where you say like, yeah, I know that this wouldn't have any x-intercepts. Or you could focus on one that's pointing down, right? A is negative and the vertex is below the x-axis. Either one of these would give you the 2 marks. So I would say diagram followed with explanation talking about both would give you 2 marks. So 1 for the diagram, 1 for the explanation. And one thing that I don't want you to say is that the vertex is negative. Sometimes students say A is negative and the vertex is negative, then the vertex can't be negative because it's a set, it's a pair, it's a coordinate, right? The y value of the vertex, sure, okay? So keep that in mind. Maybe I'll say that here just to clarify. The y value of vertex is also negative. Sure, you can say that. But don't say the vertex is negative. That's incorrect. So I will ask you for explain questions a bit more with the other unit. We were actually doing that, justifying, okay? So the next one, I will show you what I did. So I typed that into my Y1, and I'm going to graph it. And this is the same window I had before when I showed you page 11. So this is what it looks like. It's technically all right. I'm going to try zoom standard. I feel like it's very close to my origin. So I'm going to go zoom standard. Does a pretty good job. The 10, 10, 10, right? Every which way. So let's go vertex, second trace. It's a minimum, right? So I'm going to go to the left of the vertex, enter, right to the vertex, enter, enter. So that's negative 0.83, negative 7.08. And today we're just going to say if you didn't get it, then it's just -1, right? So we will say second trace min. Okay, that's what I pressed to get those. This one, only one of them applies, right? This is the only one apply. This one is an NA. There is no maximum. This keeps on going up indefinitely. So this is the equation of the minimum. This is what I was expecting there, to just state that. This is the AOS, axis of symmetry. X is equal to negative 0.83. X-intercepts, let's go ahead and find them. Y2 is equal to 0, it's already done. I'm just going to graph it. Second trace 5. Look, you just have to go a little closer to that one and just enter, enter, enter. And there it is. Negative 2.37 is the first one. Get into the habit of writing it as a coordinate, not just, I think in intro you may have just written x is equal to a number, right, for x-intercept. We want to make sure we distinguish between a point and an equation, okay? The next one, second trace 5. A little closer to the other one, enter, enter, enter. There it is, 0.70. 0, right? So we'll do the marks in a bit, okay? I'll just go back later. Y-intercept, you have a choice. Oh, hold on, second trace. I let Y2 equal to 0, and then I went second trace, intersect. We're gonna take marks off for missing keystrokes as well. Y-intercept, in this case it's in general form. I know it's that 0, -5, but if you missed it, it's second trace value x equals 0, right? So then you would just say keystrokes. Domain, like this, or -infinity, +infinity. The range, this is pointing up, so you either have this one, or you have -7.08 to infinity, round bracket, square bracket. And now we're going to do the marks. Okay, so it's going to be different than what's over here, just to make sure today we account for everything. You're going to get 1 mark for the vertex, half a mark for keystrokes. So 1.5 for that. Nothing for the maximum. The minimum, I would just give you a mark. The axis of symmetry, I would also give you a mark. For the x-intercepts, watch this. We're going to go 1 mark for the first one, 1 mark for the second one, and then half a mark for the keystrokes. Y-intercept, 1 mark. Keystrokes are optional here because technically you could do it either way. Domain, we're going to give you 1 mark. Either format is fine. I don't care which one. If you don't have round brackets, then I would say take off half today. If you have it in the right order, but you don't have brackets, right? For the range, we're going to give you 1 mark regardless of which method you use. If you have the wrong brackets, take off half a mark. If it's not even in the right order, then it's a -1, right? If you have these flipped, it's a -1 today, like if you don't have them in that order, smallest, largest, okay? So let's add this up. 1, 2, 3, 4, 5.5, 6.5, 7.5, 8, 9. Just to make things easier, so 9 for question 2. So 9 marks for question 2. 2 marks for B, 1 B. That's 11. So it's still 12. Hey, we made it work. The total for this entire thing is 12 marks because this one was worth 2 and this one was worth 1. So we're still having 12 here. So put your name, and we're going to go back to our booklets.